So if we're going to try and convert 5/12 into the decimal form, we just put some zeros in here after the decimal point, put the decimal point in, and just divide 5 by 12. 12s into 5 don't go at all. Remembering that this is sweets, sweeties, and the bottom one is people. And 12 people can't share 5 sweets without having to suck on each other's sweets, which we don't like doing. So it goes 0 times, nobody gets any sweets, and all those 5 sweets move over to the next number. So we then get 50 divided by 12, that goes 4 times. 4 12s are 48, and we had 50 up here, so that leaves 2 left over. Every child gets 4 sweets, and there's 2 left over that we move over to the next number. Then 12s into 20 go 1 time. 1 12 is 12, we had 20, so there are 8 left over. And 12s go 6 times into 80. We need to be able to approximate to the second decimal place, and then this is going to continue. We need to work out the third decimal place, chop here, that's where we're going to chop, and then we look at the number after we chopped to decide whether the 0.41 stays the same or goes up 1. So we have to always work out one more decimal place than the question asks for to decide whether this goes up to 0.42 or stays as 0.41. In this case we have 6. If it's a 5, 6, 7, 8 or 9, the one before always goes up plus 1, which it does in this case, turning it into 0.42. The reason for that, remember, is that if we were to put a scale here of the number 0.41 and 0.42, and we wondered, where is the number 0.416 on that scale? Well, here would be 0.411, here would be 0.412, 413, 414, 415. Here in the exact middle would be the number 0.415. We can see that our number 0.416 must be past the middle mark. So if it's past the middle mark, it's actually closer to 0.42 than it is to 0.41, which is why we add 1 if the number after where we're chopping is higher than a 5. Super important to remember that skill. So if I ask you to answer anything to 2 decimal places, you must work out one more decimal place than that so that you can work out whether it's to go up 1 or stay the same. Okay, 7/8. Same mechanism. Add some decimal zeros. 8's going to 7, 0 times, all 7 left over. 8's going to 70, 8 times. We get 6 left over. 8 8's are 64, we had 70, so there's 6 left over. And then we have 7 8's are 56, and we had 60, so there's 4 left over. And then 8's into 40 go 5. This one does answer to an exact number, but I've still said answer to 2 decimal places, which means you have to chop after the second number, look at the third number, this is a 5, or so the answer is 0.88. Then we have 6 8's, which we actually don't have to work out 6 divided by 8. We can simplify this to the fraction 3/4 by dividing top and bottom by 2. And we should know 3/4 is 0.75, but in case we forget that, it's not a problem. 3's into 4 don't go, 3 left over. 4 into 30, 7 times. 4 7's, 28, we had 30, so there's 2 left over, and 4's into 20 go 5 times, giving us 0.75. Don't need to approximate that. Then we had fraction form. We've got the mixed fraction, 2 and 5/7, and we want to change it all into sevenths. So we're going to put it into a top-heavy fraction. What's the technique? Step 1 is to multiply 7 by 2. 2 7's are 14. Step 2 is to add the sum that we get, this 14, with 5, giving us 14 plus 5 is 19. The answer is 19/7. Next one, 3 and 7/8. Same technique. Step 1, 8 threes, 8, 16, 24. 24 plus 7, 31. So step 1, multiply. Step 2, add. So 3 and 7/8 is 31/8. If you're not very sure that you've done these right, you can always go backwards and double check that you get back to the number that you started. So if you're not very confident in this, think about, okay, how many times does 8 go into 31? 8, 16, 24. 3 times. You've used 24 then, you had 31. So how many left over? Well, 31 minus 24 is 7. 3 and 7/8. So you can see that by going backwards from this one, you get the same answer that you started with. So you should always check those ones so you don't make a silly mistake on them. Then we had some fractions that I wanted you to convert into percentages. 9/20. You could convert it into percentage by dividing 20 into 9 and getting a decimal and then multiplying by 100 to get the percentage. But the easiest way when you've got nice even numbers down here is to convert it into divided by 100 instead. So convert this bottom number to 100 or 1,000 if you can. It makes changing percentages much easier. 25 times 20 times 5 is 100, down on the bottom. 9 5s are 45. So 9/20 is equivalent to the same fraction, 45 100ths. And I know that percentage just means parts of 100. So it equals 45%. Same thing here with 11/25. We notice that it's 25 down at the bottom. It's an easy to get 25 to 100 by multiplying it by 4, which gives us the number 100 on the bottom. 11 4s are 44, giving us 44%. You can divide 11 by 25 to also, it would give you the same answer, but it would be trickier. So always look for the easiest, quickest, time-saving technique. Then we had 11/12. And unfortunately, it's not very easy to change 12 into 100 by multiplying by a whole number. So here we actually do have to do the division. So we put in our decimal zeros. And we get 11 divided by 12 doesn't go at all. So we have to move all 11 over to the next number. We get 12s into 110. That goes 9 times. 9 12s are 108. We had 110, giving us 2 left over. So we then get 12s into 20, 1 time. We get 8 left over. We have to work out to the third decimal because we have to approximate. And 12s into 80 goes 6 times. So now we chop. After decimal place 2. Look at the number here. Oh, it's higher than a 5. So our final answer will be 0.92. Then I had some quick multiplications for you. 3 times 1.12. Well, there's nothing carrying over 10s here. There's nothing here when we multiply them through that go over 10. So I would just work backwards from here. 3 times 2 is 6. 3 times 1 is 3. Decimal point in the same place. 3 times 1 is 3. So I wouldn't even do set it all up here. I would just do it nicely, quickly and dirty. Then we have 4.1 multiplied by 2.63. Now I've got lots of numbers, lots of decimal points here, so I do actually have to set up my multiplication. 4.1. Remember that we basically ignore these decimal points, so totally ignore them for the multiplication. Okay, you can even sort of cross them out, take them away. We start with multiplying by the right hand side. 3 1s are 3. 1 6 is 6. 1 2 is 2. Then before we move one step to the left, we are now multiplying a factor 10 larger, which is why we have to move one step to the left in our answer and put in what I usually refer to as being the magic 0. It's just to remind yourselves that you actually move one step to the left in your answer. And then you multiply the 4s by everything above. 4 3s are 12. 4 6s are 24 plus 1, 25. 2 carries over to the one above. 4 2s, 8 plus 2, 10. And then we just add these numbers up. So now we've multiplied our 1s by everything, our 4s by everything. Now we just add the numbers up. 3 and 0, 3. 6 and 2, 8. 5 and 2, 7. 0 and 0, 0. 0 and 1. So we're almost ready. And this is the point where we actually put our decimal points back in. We look at the question and say, how many decimal points, how many numbers after decimal points did I have in the question? 3. So now to get the right answer, I must put 3 decimal points back in my answer. 1, 2, 3. Giving me the answer 10.783. 4.1 times 2.63 is 10.783. Super important to make sure that you put the decimal points back in the right place. And if you use the technique of just remembering how many numbers did I have after decimal points in my question, you won't forget that technique. So this is the exact answer, but I asked you to answer every question to 2 decimal places, which means that this number cannot be answered to 3 decimal places. You have to chop after the 8. The number behind is a 3, so it will give us an answer of 10.78. This is a lower number than 4, so it won't affect, than 5, it won't affect going up. So the answer to 2 decimal places is 10.78, and to be really sure that you're super clear here, you can even answer to 2 decimals. Okay? Showing that you've really specified what you're doing, that you do know that that was the real answer, but this one is an approximate answer. And don't forget the squiggly curly line there, equal sign, saying it's an approximate answer. Okay, then I said convert a couple of fractions into mixed forms. Well, 72 divided by 5. 5s into 7 go 1 time, there's 2 left over. 5s into 20 go 4 times, and there's 2 left over, so we keep that as 2/5. The 2 left over stay as 2/5. 16/5. 5s into 16 go 3 times, and there's 1 left over, so that turns into 3 1/5. Then we finish the whole thing off with a quick couple of fractions. 1/2 minus 1/8. We're not allowed to subtract fractions unless we have the same denominator. So we have to convert halves into 4/8 by multiplying top and bottom by 4. 1/2 is exactly the same as 4/8. Then I can subtract 1/8 from that quite easily. We're saying 4/8 take away 1/8. The 8's stay the same. The denominator never changes in subtraction. Doesn't go 8 minus 8 or 8 plus 8 or anything silly like that. The 8 stays the same. And then we just say 4 minus 1, giving us 3. So the answer to 1/2 minus 1/8 is 3/8. If we'd been multiplying these fractions instead, what would we have done? 1/2 times 1/8. Well, we cover the bottom 2 numbers with our hand, and we say, what is 1 times 1? Well, that equals 1. Then we put the divide line the same, and then we cover the top 2 numbers with our hand and say, what is 2 times 8? 16. So 1/2 times 1/8 is 1/16.